Hello friends, in this video we will look at numbers, the different types of sets of numbers, what are integers, what are whole numbers, what are natural numbers, what are irrational numbers, rational numbers, and real numbers. Alright, with that said, let's get started. So the very first one is a set of natural numbers. So natural numbers are nothing but all the positive numbers, and that's 1, 2, 3, 4 and so on. So it starts with 1. It's a set of all positive numbers denoted by the letter N. Okay, simple enough. The next one up is whole numbers. All whole numbers are natural numbers plus the number 0. So it includes the entire set of natural numbers as well as the number 0. That's why I have highlighted 0 here specifically, so you know that whole numbers not only includes natural numbers, but it also includes the number 0. Okay, next one up is integers. What are integers? So integers are nothing but the set of all whole numbers as well as the set of all negative integers. So it's all the negative numbers on the number line, negative 1, 2, 3, 4, 5, 0, and all the positive numbers on the number line, and that is denoted by the letters Z or Z based on wherever you are. Rational numbers. This is where things get a little complicated. Now, rational numbers are denoted by the letter Q, and rational numbers are represented by all the integers. So it not only includes all the negative numbers 0 and all the positive numbers, but then it also includes fractions, which can be represented by a numerator and a denominator, and on top of that they have to meet this criterion here. So the criteria is that when the fraction is converted into a decimal notation, it either terminates after a finite number of digits, or it starts to show a repeating sequence after division. Typical examples are of course a set of all integers, as I explained, but for fractions examples would be half, 1 by 2, which in decimal format turns into 0.5, which is finite. Again, 3 by 4 turns into 0.75, which is finite as well. So these numbers are representative of the set of rational numbers. Okay, and then irrational numbers, of course, represents all those that are not rational numbers, right? Yeah, but what does that mean? So what it means is, as through common sense, it's the opposite. So when converted to a decimal notation, that fraction does not terminate after a finite number of digits, and nor does it begin to repeat the same sequence of digits over and over. So for instance, the Greek letter pi, right? Pi does not terminate. When you convert pi into decimal notation, it turns into 3.141592, and it goes on and on and on and on. So that is the reason pi belongs to the set of irrational numbers. The same goes with most of the square roots of all numbers. For instance, square root of 2 also goes on to an infinite number of digits after the decimal number. However, other square roots, such as square root of 4, which is 2, turns into a rational number because it reduces to 2.0. Alright, that explains the set of irrational numbers, and real numbers, to end the topic, is nothing but the set of all the rational and the set of all irrational numbers. So if you think of the entire number line, uh, and all the points that you could identify on the number line, which are an infinite number of points, they are all represented by the set of real numbers, which is denoted by the capital letter R. Yep, and that about sums it up. Thank you so much for watching. If you like this video, please give your thumbs up, as well as feel free to subscribe to my channel, because I have more videos coming up for you. Thanks. Have a great day.